Unit 2, Transformations, Lesson 3, Translation. Your objectives for this lesson are to describe transformations as functions, draw translations of figures, and use geometric descriptions of rigid motions to transform figures and predict the effect of a given rigid motion on a given figure. A translation is a transformation that slides all points of a figure the same distance in the same direction. So another name for a translation is a slide. So translations are slides. And if you think about translating, if you were to translate from one language into another, you're trying to convey the same meaning. You're just moving it into a different language. So same thing, different language. This is a picture of a translation or a slide. You see we had triangle ABC, and these red lines show we've moved 1, 2, 3, 4, 5, 6 units for each point, each vertex, and we have triangle A prime, B prime, C prime. And since we're talking about translations, we'll also be talking about vectors. A vector is a quantity that has both direction and magnitude. The initial point of a vector is the starting point. So initial is where you start, and the terminal point is the ending point. So you can think of this kind of like a number line here. If I start at 0, I could go 2 units to the right and I'd end up at 2. Or I could start at 0 and I could go 2 units to the left and get to -2. So while these both have a magnitude of 2, they move in different directions. So moving to 2, I'm moving to the right. -2, I'm moving to the left. This is a depiction of a vector. You see we started at point E and ended at point F. It's kind of like a ray where you have a dot at E and the arrow shows you that you're going to F, but you actually stop at F. So this is vector V. That's how you write it, with kind of a half an arrow over it. Yes, but order really matters a lot here. You might also see this written as vector EF because you start at E and go to F. The component form of a vector you'll see written like this with the arrow sort of brackets, the pointy brackets, A comma B. And this specifies the horizontal change A and the vertical change B from the initial point to the terminal point of the vector. You'll see how we use this in just a moment. Example 1, name the vector and write it in component form. So naming the vector is pretty easy. I'm looking here and I see that I start at E, so there's a dot at E and an arrow pointing to F. So I have vector EF with that half of an arrow over it. And component form, so I have my brackets, my pointy brackets. I want to do horizontal movement first, so I've moved over 3 units. So I put a 3, comma, down 2. So -2. You use a negative for moving down or to the left. So negative means down for the Y coordinate, or left, and that's for the X coordinate. Okay. Part B, starting at G, ending at H. This is vector GH. And I've moved over 1, 2, 3, 4. So 4 to the right, gives me a positive 4, and I'm moving up 1, 2, 3, 4, 4 up. So component form is 4, 4. This is kind of like if you're thinking about slope, except you're doing horizontal movement first, but you're just really counting the number of spaces you're moving over and then up. Part C. I see I've moved over 2 spaces, and I'm on this same line, the same height, same y. I haven't moved up, I haven't moved down, so I'm going to put a 0 here, 0. And this is vector KL. Example 2, draw and label a vector with a given name and component form. So I need vector AB with component form 3, 2. So I'm going to put an A on here. You can really put it anywhere as long as you have space to move over 3 and up 2. But I'm going to count 1, 2, 3 over and up 2. So here's my B. And moving from A to B. So make sure you start your arrow on this A, the point A here, and make the arrow point to the point. You want it to end right at that dot. So this is vector AB. Vector CD with component form -1, 4. So I'm going to start this one down here. So this will be C. I'm going back 1, so remember that means left 1, and up 1, 2, 3, 4. And again, I need an arrow going from C to D, like that. Vector EF, component form 0, -3. So I'm going to put my E here. And F, I don't move over at all. And I go down, 1, 2, 3. Moving down because this is a -3. So here's F. Now I want an arrow dropping straight down. Okay, so a translation we can think about as a transformation along a vector such that the segment joining a point and its image has the same length as the vector and it is parallel to the vector. So we talked about how a translation, you're sliding a fixed distance. That fixed distance is the vector, so however long the vector is, and it's sliding in that direction along the vector. Okay. Example 3 we will work on in class, constructing vectors using, constructing translations along vectors. Example 4, draw the image of the figure under the given translation. So this figure is moving -3, 2. So you see that this is written in component form, which means that each point is going to move left 3 and up 2. We're going to do that with each vertex of this triangle. So my point here is 0, 3, 1, -1, and -1, -1. Okay. So if I take 0, 3, and I move left 3, I get 0 minus 3, and then up 2, 3 plus 2. This gives me a new point, -3, 5. So -3, 5. It's right here. Okay. Then we have 1, -1, We're subtracting 3 from the x, adding 2 to the y. So we get -2, 1, -2, 1, and -1, -1, -1 minus 3, -1 plus 2, get -4, 1. So 1, 2, 3, 4, 1. Okay. And connect the dots. Oh, not that arrow. Just a straight line. Okay. And this would be our slide, our translation. Part B, we're moving 0, 8. So let's find our coordinates. It says 1, 2, 3, -4, -4, -8, -4, -8, -8, and -4, -8. Okay. And if you think about it, looking at this, you know the 0 means the x isn't moving anywhere. And this 8 is positive, so we're moving straight up. So you can already figure that this should be in quadrant 2. Okay? So let's see if this works out for us. And I'm going to start with -8, -4. You know we're going to have -8 plus 0, then -4 plus 8, which leads us to -8, comma, +4. Okay, let's move this over here. So -8, +4 is 1, 2, 3, right here. Okay. Then -4, -4. -4 plus 0, -4 plus 8, we get -4, 4, which is here. Okay. -8, -8, what am I writing it for? -8 plus 0, -8 plus 8. So we get -8, 0, which is here. And -4, -8, last one. Okay. -4 plus 0, -8 plus 8, which is -4, 0, right here. Okay. And I have a square. It did move up 8 units. And it is in quadrant 2, just like we predicted. Okay, we have one last problem here to look at. We're moving over 9, down 5. So remember, x, y, over 9 to the right, and then down 5. I'm just going to count right on here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 1, 2, 3, 4, 5, right here. This one, if I go over 9, it's going to be over here because this is straight down, this will be straight down. So over 9, then down 5. 1, 2, 3, 4, 5. Okay. Over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 5. 1, 2, 3, 4, 5. This point over 9 is here. Down 5 is 1, 2, 3, 4, right here. That onto the point. And all we have to do now is connect the dots. Here we go. This is our drawing. Beautiful, beautiful translation. Slid from quadrant 2 to quadrant 1 and quadrant 4. And that is all for translations. We'll do those constructions during class.